Hello learners, today I'll be discussing on the topic in the probability. We have Bayes theorem. I'm not getting into the depth of the Bayes theorem, but here I'll demonstrate what actually is a Bayes theorem and how to solve the practical problem using Bayes theorem. It is basically again a important concept in the probability and especially in the statistics we use to update the probability of a hypothesis as a new evidence whatever it is available. So here this particular concept which connects with the prior knowledge with the new data. So here we will be taking two things. One is prior probabilities and posterior probabilities that we consider. So in general the theorem which is mathematically expressed as P bar A is equals to P A of B into P of B by P of A. So here this particular P bar A, the probability of event B given that A has occurred. For the event of B, A has occurred. Suppose if you have AB, for the event of A, B has occurred. So in the same way here we have this is nothing but the likelihood, and it is the probability of event A occurring that B is true. Event A is occurring because B is true. Here event B, in the event B, A has occurred. So posterior probability, that's why occurred. So already occurred in the sense it happened already. Likelihood, so this is the likelihood. That means it may happen or it might have. It may happen. Likelihood means the chance may occur. So I am considering this as a true. So P of B, which is considered as a prior probability, and P of A, this is a prior probability and this is the marginal probability. So where this probability, marginal probability, which can be written as summation of Ni is equals to 1 P of the probability of event A occurring when B is true into P into B of I. So here this B is taking multiple mutually exclusive events where it may be B1, B2, B3, so on. Okay. So Bayes theorem actually it provides the systematic way to update our beliefs or predictions based on any new evidence. So why do we use Bayes theorem? Because it because here we are taking prior probabilities as well as posterior probabilities. So here we will be having the knowledge about the prior as well as the new data, so which we can integrate into the probability calculations. So whenever new data available, immediately we can update because the probabilities can be recalculated with the new data also. So this particular theorem is applicable, used widely in even medical field, even in business operations, finance, marketing, even in the artificial intelligence also. We are using this Bayes theorem. Suppose if there is a incorrect or biased priors, because here in this Bayes theorem we are considering the prior probabilities. If the prior probabilities itself is maybe unbiased data is there, or maybe that may be incorrect data. Incorrect, if you have incorrect prior data, then even the results, whatever the results we find using the Bayes theorem may mislead us. So that is one of the important limitation of the Bayes theorem. Now before getting into the thing, let us look at a small problem. So here we have the problem. So in a bolt factory, machines A, B and C manufacture 25%, 35%, 40% of the total output respectively. Of the total of their output, 5, 4 and 2% are defective bolts. A bolt is drawn at random and is found to be defective. A bolt is drawn random and is found to be defective. So here we need to find out what is the probability that it was manufactured by machine A or machine B or machine C. So through this problem we consider that. So here we have to draw a bolt from the event. So let AI, that I, where I is equals to 1, 2, 3, drawn a bolt from machines we have machine A, B and C. So in the problem we know that machine A, B and C manufacture 25%, 35% and 40%. So from the data we know that machine A, so I am considering this a probability of A1 has 25%, so 25% means 0.25, probability of A2 25, 35%, so 35, and probability of A3 which is 40%, so 0.40. So again there is another information. What is that? In the problem, a bolt is drawn at random and it is found to be defective. It is found to be defective. Of the total of their output, from the total of the output, 5, 4 and 2% are defective bolts. So B, the event of drawing a defective bolt, so here P of B from A1 is how much? 5%, 4%, 2%. So 5%, that is 0.05. So we of drawing A2 0.04 and P of BA 3, that will be 0.02. See from the data P of A1. So whatever is the data he has given, what is that? This one is 25% of the total output. So this is 35%. So machine A, B, C. So I am taking here this A as an event of drawing a bolt produced by machine A, B and C. So here what I am taking? The event of drawing a defective bolt. So bolt from a machine and drawing a defect bolt. So what we need to find out? The probability that it was manufactured by any of the machines, whether it may be machine A, B or C. So here what we do is we calculate the posterior. These are the prior probabilities what we have. 0.25, 0.35, 0.40. Prior probabilities. But what do we want? We want posterior probabilities. Posterior probabilities we need to find out. So here we will be calculating the posterior probabilities. So I am calculating in the form of table. So posterior probabilities. So how many events we have here? Event. How many events? A1, A2 and A3. Prior probability. What we have? 0.25, 0.35 and 0.40. So this probability should be equal to 1 always. So we have conditional probability. What is that conditional probability? Drawing a defective bolt. Based on the event A. So what do we have? 5%, 4% and 2%. So 0.05, 0.04 and 0.02. Now in the problem, so we have prior probability and conditional probability. So what we will be calculating? We will be calculating joint probabilities. So how to calculate joint probability? 0.25 into 0.05. So look at 0.25 into 0.05. So we get 0.0125.